This is the fourth problem on the AP Physics 1 problem set, Chapter 2. And it reads, a ball is thrown upward by a person on top of a 50-meter building. The initial velocity of the ball is 5 meters per second upward. Find the following. So we're going to draw a picture first. So I draw a picture, then I'm going to have hold on, I got to get a marker here. That was good. So I've got this building 50 meters high. So we're going to call the ground 0. That's part of your coordinate system, is figuring out what your coordinate system is. And our initial height, x naught, is 50 meters. And we're throwing this ball upward. We could throw it downward if we did. It'd be a negative velocity, but we're throwing it upward, so that's a positive velocity. And that velocity is 5 meters per second. So it's got an initial velocity of positive 5.0 meters per second. All right. So we want to know the position of the ball at the top of its trajectory. So in other words, I want to know x. Well, if I look at what I got, I also know this. When it gets to the top of its trajectory, that means it's going to stop and turn around because the force of gravity is pulling on it, and the acceleration due to gravity is, that is our acceleration, and it is negative 9.80 meters per second squared. All right. So knowing this, what equation would I use? When you look on your equation sheet, I believe it's the third one, and we'd use that one because we don't have time in this. And that's v squared equals v naught squared plus 2g, and we'll just go ahead and say delta x. It's actually going to be x minus x naught. But for this part of the problem right now, we're going to call this right here, where the ball's thrown from, 0, just to get what x would be. And then we have to add 50 to it when we're finished. So 0 equals 5.0 meters per second. We're going to square that. Plus 2 times negative 9.80 meters per second squared times delta x, which is what x minus x naught equals. So those two right there are just that. So the only thing we don't know here is delta x, so it's going to be 0 equals 25 meters squared per second squared minus 19.6 meters per second squared times delta x. And I have to subtract this over here, so I get negative 25 meters squared per second squared equals negative 19.6 times delta x. And when I figure this out, then I'm going to get delta x equal to, and when I did it, I got 1.3 meters. Now that's above from where it's thrown. If I want to go from the ground, I've got to add 50 meters to that. So if I add 50 meters to that, I ended up with 51.3 meters. So there's our answer from the ground. Both of those will be correct as long as you explain, unless the problem specifically asks you, height from the ground. It's just the position of the ball. So 1.3 would be correct if we're measuring 0 from the top of the building. So yeah, right there. All right, B, the time to move to the top of its trajectory. There we go. So now we're going to go figure out how long it takes to move to the top of its trajectory. So in other words, how long does it take to go from the thrower's hand, from when it leaves the thrower's hand to 1.3 meters. So that's going to be our B part. Let me do that in a different color so we can tell the difference. So this is the B part. And I'm going to use, I think it's the first equation, V naught plus GT. Remember, A becomes G when you're talking about vertical. And so I know that's 0. I know that's 5 meters per second minus 9.80 times T. So it's going to be negative, you're going to move that 5 over here, it's going to be negative 5 divided by negative 9.80, and you're going to get T equal to 0.51 seconds. All right. C, we want the total time in the air now. Well, that's going to be how long it takes to go, let's do this in blue. And I'm going to zoom out just a bit so we have more room. All right, so the second part of this is the total time in the air. So that's going to be, and I'm going to do this in green. So it's going to be from the thrower's hand all the way up here, 1.3, and then all the way back down here to the very bottom to 50. So we know from here to here is 50 meters. And we know from here to here down is 1.3 meters. That's where we get the 51.3. So to do that one, I'm going to use the second equation, I think it is. X equals X naught plus V naught T plus 1/2 GT squared. Again, remember that A becomes G. So that's X naught is 51. Well, let's just put them in. X is 0 equals 51.3 meters plus 0. In other words, this whole thing here, V naught is 0. When it's up here at the top, it stops. So that whole thing is 0 when it starts falling. Minus, all right, we're going to learn to do a shortcut here. 1/2 times negative 9.80 is negative 4.9. If you have that memorized, use it. Otherwise, do 1/2 times 9.80 and you get negative 4.9 meters per second squared times T squared. I don't know. So when I move this over here, it becomes negative 51.3 equals negative 4.9 T squared. And all I have to do now is divide both sides by negative 4.9. Of course, the negatives divide out. I'm left with positive, which is good because we only have positive time. And then take the square root. So these become positive. And when I take the square root, I get T equals 3.24. And then if I want total time in the air, I'm going to have to add to that. I don't know what my answer is, but anyway, I'm going to add to that the time at the top, which was 0.51. Not sure if I added that in my original solutions. So 3.24 seconds is how long it takes to fall from 51.3. But if I want total time in there, I have to add the 0.51 to that also. So that's going to actually be 3.75 total. Yeah, 3.75 seconds total. if I add that in. If I just want to know how long it takes to fall from the top, then it's 3.24. And that's how you do that problem. Hope that was helpful.